So this one says x and y are integers such that x is bigger than or equal to 2 and y is less than, x is less than 3 and y is less than or equal to 4 and bigger than -1. Find the values of x and y when x is equal to y. So for this one, I drew a number line and I thought about, okay, well, x can be equal to -2, -1, 0, 1, 2, but it's less than 3, so it can't be equal to 3. And then y, which is this line represented by this line underneath, is bigger than -1. So the next value could be a 0, 1, 2, 3, and it could be 4 because it's less than or equal to it. The key with this question is the fact that x and y are integers, which means whole numbers. So then, if I think about the values of x and y when they've got to be the same as each other, the only time where x and y could be the same is when it's equal to 0, 1, 2. X can't be equal to 3, so 3 is not included, and y can't be equal to -1, so -1 is not included. So the answer for this one is 0, 1, or 2. Okay, question 8. Right, which person, Keith, Ben or Liz, will have the best estimate for the probability of getting a head on this coin? So we've got a table here, where they've thrown a coin, so they've each thrown a coin to see if it was biased. Bias basically just means whether it's like weighted to a particular, giving a particular outcome. They each threw the coin a number of times. They counted the number of heads and the number of tails they got. So Keith got 12 heads and 28 tails. Ben got 34 heads and 66 tails, and Liz got 57 heads and 243 tails. Now the key with this question is not working out who's got the biggest probability of getting a head. It's working out the total number of times that they've thrown the coin. So Keith threw it a total number of 40, Ben 100, and Liz 300. And basically the answer for this, you're wanting to put the fact that it's the person that's thrown the coin the most number of times. That will give the best estimate for the probability of getting a head on this coin. So you're using like an experiment to represent the best estimate of a probability. So the answer for this one is Liz, because she's thrown the coin the most times. She's thrown it 300 times. Right, using all the results in the table, work out an estimate for the probability that the next throw of the coin will be a head. So for this one, I added up the number of times they each got heads, and I divided it by the total of all the number of times that they'd thrown the coin. So there's 28 plus 66 plus 243 plus these ones here. So it's 103 over 440 for that one. Okay, right, question 9. Question 9 is a bit of a disguised question because it looks like a straightforward perimeter, but this is actually a similar shapes question. So it says D is a point on AB, so that's there, is on there, and AB and E is a point on AC, so that's on AC. DE, so this line here, is parallel to BC, and AD equals 4 centimetres, DB is 6, DE is 5, and AE is 5.8. We want to calculate the perimeter of this trapezium here. Okay, so what I started off by doing, because we've got two triangles inside of each other, and because I know that these two lines are parallel to each other, I know that this angle in here is exactly the same as that angle there. That angle there is exactly the same as that angle there. And this angle here in this triangle is the same as the angle in this bigger triangle. So basically I've got, because all the angles are the same, I've got two similar triangles that I can draw from this diagram. So the yellow highlighter one's there, and I've just redrawn that there, and I've written on all of the sides, which have been given. And then the bigger one, which is the purple pen one, which you can kind of see, is round there, and I've written on that's 10, these two lengths, sorry, we've got to work out. So my scale factor to get from my smaller triangle to my bigger one is 2.5. So to get from 4 to 10, I need to multiply by 2.5. So then I can use that to work out these two missing lengths here. So I do 5.8 times by 2.5 and I get 14.5. And then 5 times by 2.5 gives me 12.5. So now that I've got that, I can use those lengths to work out the perimeter of my trapezium. I can say, well, we know that the top part of the trapezium is 5. We know that this length down here is 6. And these two lengths we've just worked out. So this whole length is 14.5. So if I know that this one's 5.5, if I take it away, I get 8.7 here. And then as well, we've worked out the bottom here is 12.5. So now I add all those lengths together to get the perimeter of 32.2.